Okay, right. So without further delay, let's start by talking about how to actually create a so-called generic class. So what's the rationale behind having a generic class? Firstly, let's start writing a simple class. Okay, so for that purpose, we can create a simple Java application program. You don't need to include any library. So therefore, for the usage, we can just use a normal Java application with no build tools. That means you don't actually have to use any of those so-called project manager such as Maven, right? So over here, we are going to create a generic project, right? And I would just want to refresh your memory a bit about firstly how to create a class. Of course, this you would have already known. Okay, say that we want to create a class called, okay, what's the best name for it? Okay, let's say I want to create a generic box or whatever. Okay, so let's give it a good name. Let's say I will call this as people, right? So for a people class, normally when we create a class, we need to actually create a class with probably some private variables. Okay, that means it's basically local to the class, right? So these are local variables, and then you may have things like, let's say, string name. Okay, so one person will probably have their names and so on, and then for our constructor, we would have public people followed by a string input, which is your name, right? So this will be used for initialization, and we normally will assign the local variable with the initialized value, right? And then we also have what we call as a getter and setter, right? So you basically, how to write a getter? Getter obviously will have to return a value, right? So that value that we normally will return will depend on your let's say local variables that we have. So here we are using string, so therefore your get people will return that particular or I'll call it as get name. Get name will be more direct. So then this should return name. So I'm just going to do this so that you can see how we actually started from the original, but we can actually make it into a generic class later, right? So over here, for our normal method, of course, you can actually have a getter and a setter, right? So set name, of course, requires an input parameter. In this case, it has to be given an input parameter or of type string, and then we would do the same thing like during initialization. Okay, so that will be the very basic parts and pieces of your people class, right? So if you want to, let's say, change the people class data into, let's say, say that I need to have ID, and then the ID is integer, for example, and then I will need to add in a variable, right? And then you notice that somehow you would probably have to also change your constructor in such a way that it provides that particular so-called input parameter, right? Integer I, for example, and then now you will put ID is I, right? So with that, of course, you notice that this becomes a bit troublesome, right? So if I just want to have one of that, then I will need to change the type from time to time, right? So like, for example, if I were to just use ID instead, so then this we will comment it out, and this will become integer I, right? And now your name is no longer required, so therefore you are going to change a lot of places, right? You notice that your return type, everything has to be changed, and this is not convenient, right? So why don't we actually have a method that allows us to do things more neatly? So therefore, looking at this people class, we could have actually done something similar, right? I'll call this new class that we want to create as people2. So we create a new class called people2, and this new class, we are going to have the same structure like this, but we are going to use a generic method to add in the parameters as well as the input output. Okay, so say that we only have one thing to input. Okay, we don't want the ID over here. Okay, and we want this to be flexible. Okay, firstly, the private variable inside should be flexible enough so that we are able to actually use it to create multiple so-called generic classes that we can use, right? So here is rigid because the type is string, right? So how to actually make it flexible? Firstly, after the class name, you could have added this so-called type specifier, an angle bracket, right? So the type specifier can be put after your class name, right? In your class definition, public class, then your class name followed by the type specifier, right? So type specifier over here, you are going to use the angle bracket, okay? So when you use a type T, that means you can substitute the type that you have inside with just T and without worrying about whether the T is integer, string, or double, or whatsoever. So you can use that type. Of course, this type will be, we call it as a class type, okay? Class type. So let's change this to T then. So now, since we are using T as the type over here, so then you are going to change all this as a T. Then, as long as they are of the same type, then you notice that, well, it can be accepted, right? Now, okay, so if you put string as the type specifier, right, you specify the type string, then when you create people2 of that instance, then it accepts only string, all right? So let me just show it to you. So once you have declared something like this, then how do we use that? Okay, let's come to our app.java here, and we declare the instance, right? So the traditional way, when you create people, you are bounded by the type, right? Because you need to know what the type is, okay? People P, let's say P1, okay, is new instance of people. And then I will have to basically put in, like, for example, the name followed by ID, let's say 1, something like that, right? So this is one example. And then you notice that it becomes a bit inflexible because here you can only use string, right? So whereas when you use people2, what will happen? So if you declare people2, the first thing that we notice is you are basically going to specify a type specifier, just like in the case of your array list, right? We have used array list before with an angle bracket that allows you to specify the type. If I say here is string, then this P2, I can just say new instance of. Now, automatically it infers that this is a string. Although we actually put the constructor as a T, right? If you look at the type over here, so we are typing halfway, and immediately when you use string here, so the constructor has a T input parameter, right? And this automatically becomes string, right? So I don't even have to worry about type safety because now automatically it's checked for me. And okay, so this is the next example. And if I want to create people2 with integer, then okay, then you notice that now it's becoming integer, right? So if you use that template structure, the T, right, the type specifier that we use, then you notice that all of a sudden it becomes so flexible now. I can even, let's say, put in number, right? People2, sorry. And take note that, of course, here now it's not used, so therefore you notice that it says it's not used, okay? And then when you declare a raw type, don't forget that, okay, initially this is okay, right? Because there's no type specifier. But when you have a type specifier, remember that here, just to make it okay, you would have to put this angle bracket as well here, right? Just like when you use array list and so on, right? So if you don't put, it doesn't mean it's wrong, but it's just say that, okay, the type has to be specified. But if you put an empty angle bracket like this, it automatically infers the type from your definition, right? That means when you declare a variable, people2, called P2 here, so then it automatically infers, okay? Automatically infers this to be a string. So if you want it to be complete, of course you can type in, then that completes your declaration of an instance, right? Is that okay? So if you don't put in, it will still be okay. So therefore, you must make sure that all these are properly inputted. And now if you use the method p2 dot, okay, so like let's say I say get name, what do I get? So you can always use system.out.println as a test platform for you to actually output the results. Okay, so here what we are going to do is we are going to do that for all of them. Okay, that is P1, P2, and P3. Okay, so then you see the flexibility in building programs now if you use something like that. Okay, so now it prints Steve. Okay, here I will change it to Theo, right, better, so that you can see the difference. Okay, so first definition, of course, this is the old way. New people, and then whatever parameters they want to pass in, and that makes your class very rigid, right? You have to follow precisely what you have here. But now if you use a class with a template, well, actually you can use it on different kinds of definition, right? Whether you want string or whether you want integer or whether you want double, whatever, you can save inside there, right? So is that clear to you though? So now it makes your class more versatile, right? It is not bounded to just one type. So the type will be inferred when you have the compilation, right? So during compilation, your compiler will look at it and figure out that, okay, since you have declared t to be a string, then it automatically assumes that the input parameter will be a string, right? If you type anything else other than a string, it will not accept it. So during compilation, all this checking will be done, right? Instead of runtime, okay? Many times you notice that things can blow up very easily if there's a runtime error, right? But with a generic definition, then the checking is done during compilation time, right? So therefore, it's harder for you to make any mistakes, all right? And it makes your program more versatile and reusable. Now, I can create a generic class like this and reuse it anywhere, right? So that's the idea, in fact, behind all this so-called generic definition. So is that okay for you? Right. And another thing I want to mention to you is that some people ask about this type specifier. Must it always be a T? Well, it can be any name, right? If you want X also, you can use X here. But all of them you have to change to X, Okay? Is that okay for you? So hopefully you understand that this type specifier is just a symbol that you use to replace the type. So for the time being, I do not restrict the type. Okay? So that means it's open type, open class type. Right? So when I say class type, that means it can also be a class over here. Right? And by right, if you look at what we use here, if we use string, capital string, that means it's a class. Okay? So it is different from our primitive data type that we use. Like for example, you still remember your integer, right? Small letter, right? So the primitive data type is just for you to store data, right? So those are storage for you to store certain types of data. But if you use integer class, the integer class comes with methods, associated methods. You notice that, right? This is a class. So therefore, when you put a dot, it follows by some of the methods that you can use, like pass integer to string value of, okay, which can be used to check the value of certain integer or value of a certain string input, whether it's capable of converting it into integer or not, okay, or converting to hex string also, right? So now you notice that whatever we pass here is actually a class type, okay, class, right? Okay, so not just a primitive so-called type that we use for defining your variables, all right? Okay? And of course, another thing is, shall this be one character only or it can be XYZ? Well, actually you can have XYZ like this, no problem, all right? So as long as you stick to the same name, it should be XYZ, right? So let us just copy the XYZ and paste it to show you that it still works, okay? If you rename it to more than one character, it will still be okay, but you've got to stick to that name, right? But for our so-called naming convention, normally we assume that we are going to use the same name throughout, right? And for ease of recognition, sometimes it's better to use one single character for your type specifier here, right? So for generic type specifier, we are going to use a angle bracket with some arbitrary alphabets there. All right? So is that okay for you? Right. Part 1, in fact, if you look at your tutorial questions, okay, we have already covered generic class, right? So the last part of our tutorial, in fact, we are covering generic class followed by generic method, okay? So I don't want to actually refer you to all these things because then it makes things not so lively, right? When you look at static things, right? So when you explain from slides and when you actually do the coding and show the coding is actually different, right? So if you look at this example, okay, this is a class example. And you notice that we are creating a so-called generic box, okay? And the constructor plus the getter and setter are all here, right? And you can see that we are using the T to replace the variable, right? Okay, so some people are scared of using the so-called arbitrary type over here. But what you have to do is just you remember the position of the parameters and return values and then just replace them with the type specifier when you want to use them. Okay, only the top will have an angle bracket. The bottom, no need. And only when you are actually declaring an instance, you need to use the angle bracket. Left and right, okay, left and right must have angle bracket, right? In the declaration statement, you must have angle bracket on the left and right. But on the right hand side, you don't actually have to specify the type. It follows whatever you have on the left, right? On the left, if you define once, then it's good enough for the system to know what type you want to use, all right? And then on top of that, of course, this will be just a class that uses a generic T, right? All the way. What if, let's say, you want to use just a method, okay? Just one method that I want to use with a generic type. Then what should I do? Okay, so this is something trickier than previous example. Previous example for T, for class definition is very straightforward, right? But how about for our, okay? Let me just, okay, make it longer, right? Let's say, okay, so let's say I have a compute method. Okay, I don't want compute. Okay, what is the best one? Okay, let's say print. Okay, print data that accepts some arbitrary data that you want to actually print. Okay, so if you have a print data method, normally this is how it looks like, right? Because you got to have a void return type. And the print data normally doesn't return a value, right? So this is one example. And if you want it to be able to print not just one type of data, so what should we do? So say sometimes if you say print data integer, then your print statement will be like this, okay? System.out.println, and then this becomes I, right? Which is integer. How about if you want to change it to string? So normally what people will do, can you just add another one with a string like this? Will it work? Why not? Right? Why not? Well, it will still work. So you remember that this becomes what we call as method overloading, right? Method overloading. So therefore, you have multiple methods with different signature, right? Okay, so then you have already learned about this thing. And sooner or later, if you have all kinds of input that you want to do, headache, right? Your coding will be that long, right? For all possible data types. So how do we actually simplify this one? Is it possible for us to just use one generic way to do it? You would want it, right? So that will make your coding much easier. So how do we actually do that? So the easiest way, of course, is to look at all the possible variables that you want to use here and take note of the parts of your method definition, right? So we start by talking about the modifiers, right? So the first one that we have, they are the modifiers, public and static, they are modifiers, right? And followed by your return type, okay? Return type, followed by, so I'll make it further, right? So that you can see. Modifiers are in front, then your return type, followed by your method name, right? Method name, followed by your bracket input parameters. Agree? So this is your normal method structure, right? And then how do we actually make it generic then? So to make it generic, you got to actually put a so-called type specifier somewhere before the return type. and after your modifier, right? So like here, we put a T, right? So that is just a comment. So in actual practice, you put a T here. And then now I can put a T behind. There you go. So now the print data, how to use it, right? So now it's more versatile. You just need one definition. It works just like method overloading, right? Method overloading where you can have one method with multiple signatures, right? Well, multiple different signatures. So now to actually use that, you notice that now I can use from people side. So how do I do that? For people side, I just say P1 dot, okay? So then I have print data, and you notice that it's a T bracket I, right? The T data type. So how do I actually define the data type then? The data type will follow precisely, okay, what you put into your print data, okay? And then say I print string here, okay? So how do I actually use it? So remember that here it says that, okay, you got to actually say string somewhere. So where do we place the string? Okay, so for the string type, okay, so over here you got to actually have print data string from people should be accessed in a static way. So therefore, actually, sorry about this. You don't actually need the type. So this will have to be a class called people. Okay, all right. Okay, I just forgotten that I've declared a static. So when you use a static, you have to use the class name, right? Class name dot method name, right? Instead of using the instance name, right? Is that clear? So there you go. Now when we use print data string, it prints string, right? Okay, if you can't see it, never mind. Let's just move this up a bit so that you can see whatever has been done. So it prints string. If I put in integer, let's say 99, it prints 99, right? So now your method is so versatile. It is not tied to a class. You notice that there's no class generic type that we actually put up there, right? So no generic for the class, but only generic for this method. Okay, so this method, public static angle bracket T void print data, allows you to print any kinds of data. All right, so now let me just compress it together. Now you can see the code much clearer this way, right? So is that clear to you? So actually you can define a generic data type for your method only, right? Not necessarily it has to be applied throughout the entire class. All right, is that okay? Right, so once you have learned all this, then it's easier for you to actually see how the thing works, okay? So now, for using the type, you notice that there's no need for an angle bracket, okay? No need for an angle bracket because it's not a so-called class, right? So the class definition will require an angle bracket. Here, the usage will determine the type, okay, for method. Okay, for generic method, the usage that you have here will determine the data type. So therefore, you don't need to use an angle bracket for a generic method. Is that clear? All right? Okay, good. So once you are clear about this thing, then obviously the next step will be much easier now. All right? So the next step that I want to actually mention is on, okay, generic interface. We have written interface before, right? So how do you actually create an interface? So what's the purpose of using an interface anyway? So an interface allows multiple inheritance, right? You don't want that particular structure to be just applied to one certain class, right? It can be used by multiple classes. So it allows multiple inheritance to be created. So therefore, if we create a so-called interface, our normal way of creating an interface will probably be like this, okay? We just say, okay, public interface, INF, right? And in the interface, probably you would have all the corresponding abstract method, right? Abstract method, okay? So what are the abstract methods that you want to put in? So like for example, I would want to have a public, okay, void print data, for example. Everyone should do a print data. If you let's say implements this interface, then all of you should be implementing the print data, right? So I just define the structure that you need to implement, but I do not tell you what are the internal workings, right? So anyone that implements the interface must create their own print data, for example, right? Okay, so how do we actually use that in our classes then? So this is normal, right? Because there's no data type involved. The normal interface will look like this, okay? And then you have all your so-called abstract methods defined over here, okay? And in order to make it into an abstract, in order to make it into a so-called generic interface, so an interface that allows any data type to be associated with it. So what should we do? Okay, so in order to use this, you would add, just like in the class, a T behind, right? And then, like for example, your print data will accept T, okay? Something like that, right? But you don't implement the body, right? There's no curly brace body inside this particular interface. So therefore, how do you actually use a generic interface in our class definition? Let me just use another example, okay? So here we create a new class called people3, okay? People3. And in people3, if we want to use the interface, what should we do? Is it going to be extends or implements? Interface, okay? Be careful. Interface, we use the keyword implements, okay? Implements. And then the interface is called INF, but don't forget that you got to put a type for it. What's the type that you want to use? For example, you want to use string. And once you have that defined, you notice that immediately your people3, there's a hint that says this must implement something, right? What should you implement from the inherited abstract method? Interface of type string, right? Okay, so therefore it expects this to have print data string. So therefore you must implement public, okay, void print data, and then you are supposed to have a string input. Same type, okay? And then you must have the body as well. And inside here, this will be your body of your code, right? So remember that once you implement an abstract interface of certain type, you must use that certain type in your abstract method, right? So most likely it will be associated directly, okay, something like that. And if you were to create another interface, okay, for another class, right, called people4, and say that you have another class, okay, I just want to show you how implements interface. Can it be integer then? Yes, you can. Okay. And then this people4, of course, should be in a different file. Don't worry, I will move that over shortly. So then your print data will become, I just want to put it side by side so that you can see it, okay? Then it becomes integer, right? N, for example. So it need not actually have the same variable, whatever. So then this will allow you to, okay, print N. Right? So then this will be the code that you put into a new class. Don't worry. What we'll do is we'll move it over, because here it says it needs to be in a new file, right? So as long as you put them in a new file, then it should be okay in a new file, right? So there you go. You can see that the difference is only the type, right, during implementation, right? So when you implement that interface, you can actually implement it with certain type, right? Although you have the same structure like before, and you look at the interface, you just define once, right, what you want. So is it much more convenient now? It's much more convenient, definitely, right? Because you are actually having code reusability here, right? You can reuse back your original definition without worrying that it's going to affect multiple places. So you just define one standard format for everyone to follow, and then everyone will implement their own generic interface using an arbitrary type, right? In this case, it can be any type, right? So that's for the interface. Remember that you can use an arbitrary type here, and because it's used in your method, right? In your abstract method, then you notice that now everybody can implement their own, right? If you look at people 3 and people 4, is that clear? Good? Okay, so therefore, that's what you need to know for our tutorial, right? We still have 2 more parts to go. It goes deeper and deeper. You notice that we are actually going from the very basic, okay? We have generic class, then we go on to generic method, right? If you look at this generic method, of course, it's basically a method to swap the elements inside an array. So it accepts an array of any type, right? T bracket means array of any type. And then it uses index I and j. This is very dangerous. Why I say it's dangerous? Because you notice that your array can go out of bounds. All right? So this is not a very perfect program. For your info, if you were to use it, be careful, because here the example only uses, like for example, integer array with 3 elements, and then a word, okay, that means a string array of 3 elements also. For the numbers array, we are going to actually swap index 0 and 1. That means these 2 will be swapped. And then for the next one, we're going to swap 1 and 2, which is basically these 2, right? So these 2 elements behind will be swapped. And of course, it will print out the actual swap array afterwards, right? But you notice that you need to actually put a guard statement here, right? So if you don't believe, you can always, okay, grab this code and I'll show you why it will fail, right? So this is a generic method example. Let's put it in here. So we have a generic method example that we want to actually look at. And this is the generic method example, right? I have a typo, so sorry about that. Let me rename this to the right one. Capital and small letter methods, okay? So therefore, be careful, right? Generic method example, okay? Right, so now, do we have the right name? Okay, so don't worry. Now the name is the same. Now we save it. It's okay now, right? So this example will work normally as long as the index is correct. Okay, so when you run this one, okay, as I mentioned to you, when you swap these 2, it becomes 213, right? When you swap this, it becomes 132, right? So that's the output. And what if you use the wrong index? For example, I use index 3. Will it run? You get a so-called array index out of bound exception, right? So with that example, of course, it means that this program is not foolproof. How do we foolproof it? Okay, there are 2 things you need to check. The index I and j, right? So how do we actually check that? You should actually put here, okay, an if statement. And that if statement will only be carried out, okay, if the check passes, then you go and change the so-called swap the array. Okay, so what do we need to check? Firstly, you got to check the array, right? Array dot length. Okay, so if let's say your I. Okay, so what are the things that we need to check for I? I should be less than or equal to your array dot length. Okay, so that's the first thing. And your j should be less than equal to array dot length. Okay, I and j, sorry about that, I typed wrongly. So these are the 2 things that you must check so that your code becomes correct. Okay, if not, then it will not be able to actually allow you to continue, right? So then this is the, you need to save it. Okay, makes a roger out of your code just now. Okay, so okay, so are we closing it correctly? No. Okay, so this one closes this. Did I miss out anything here? Right, okay, yeah, sorry about the bracket. I forgot to put a bracket to actually enclose the items. Okay, there you go. All right, so once you have actually got this one, the checking, what can we say about the checking? Where is the code that is wrong somewhere? Did I actually put something wrong here? Okay, let's check the typo. Any typo here? So, okay, there's one missing here. Right, one is to enclose this one. This one will be to enclose the class. Anything else? Okay, that should be done. All right. Now you have index 3 out of bounds, right? Why? Okay, so why is it still not checking for your I and j? Right. So you cannot have equal, right? Less than is the correct one. Equal, like for example, if the array length is 3, you cannot go up to 3. It's 0, 1, 2 only, right? 1 less than. So therefore, this should be the correct one. Okay. So it only swaps. Okay. Does it swap anything? No, right? Okay. Because firstly, if the index is wrong, it will not print anything. Okay. Apart from those that you have actually allowed. Okay. I think there's a missing line just now. I think I deleted some, right? So this will be for words. Right. If it's successful, definitely it will change. If not, then it will not change anything, right? But bear in mind that I did not check for less than 0, right? Can the index be less than 0? No, right? So then you got to actually make sure that the index I and j also is not less than 0. If not, then it will still blow, right? So therefore, I say that this is not a safe program to go for, right? And then the next example is on interface. So this interface is called sizable t. And what I want to highlight here is that it has a method that you must implement with a certain type t, right? And that's called compare size. And you notice that once you define this interface in your box class that you implement sizable, you must actually have a constructor for it. And inside the constructor, if you have declared, okay, integer as, right, over here, you notice that you're actually using integer, right? Okay. Remember that this sizable t, the t can actually be a class, as I mentioned to you before, right? Then if you say a sizable box, that means it follows what your class definition will be, right? If your box comes with, okay, the constructor like this, then the type that you use here is integer, right? And next, during the comparison, right, the compare size with box other. So how do we actually compare the size of these two boxes? So it means that one of them will be your instance class here, right? Compared with a reference that you pass in, right? So we are comparing the integer value size of your current instance with the size value of the references that you pass in. So therefore, you notice that this is basically what is done. And what happens here is that you use an integer.compare method, right? So this integer.compare, notice that it's capital I, right? The compare will allow 3 possible values to be returned to you when you compare these two, right? If the first parameter is less than the second parameter, you are going to return a -1. If the first parameter is equal to the second parameter, you return a 0. If the first parameter is greater than the second parameter, you return a 1. So this is actually mentioned below, right? So the compare will return -1 for less than, 0 for equal, and 1 for more than. So when you use this code, then you will be able to actually compare the size of the instances, right? So like here, we have small box defined with a size 5. Big box defined with a size 10. And we use the compare result from small box, right? So that instance that you use is small box, compared with the pass-in instance, big box, right? So the big box value is actually 10. When you compare 5 with 10, it should return -1, right? Okay, so then you already understand how this thing works. Okay, so next, for bounded type parameter, okay, sometimes, right, for bounded parameter types, sometimes we want to create a method that you can actually use. So over here we have already got method. Okay, this is a generic method, right? Sometimes you want a method that can actually allows you to work on multiple data types, right? Like for example, we want integer, double, float, and so on, but not string. Okay, so example of those type of method will probably be, in this case, we put t first. I will come back to this one later, right? And then your method should be called, like for example, sum to number, right? Sum to. So for the sum method, of course, we want it to sum the first value, v1, and the second value, v2. And because of that, the value that you should return should be v1 plus v2, right? But you notice that this t doesn't allow all the types to be used. Why? Because you must have a type that is actually able to be computed. And those are what we call as number, right? The number type. So therefore, in order to actually use that, we can use the extends keyword here. Okay, t extends number. And then over here, our t is supposed to be used below, right? So the return type for the method, we can actually use the following. Okay, and how's the return type then? We could use a double for return, right? Okay, is that clear? So I'm actually showing you how to write a method that can return a double value based on what you input here. So it can be integer, double, or whatever, and then the final result will be all converted to double, right? So this is what we call as a bounded parameter type, because you are actually bounding this type t to just numbers. So it can be integer, double, float, or whatever. So when you have an angle bracket with some keywords like t extends number, that means it's a bounded parameter type. And then this boundary, the boundary can be lower bound or upper bound, right? So because you are actually allowing extends keyword, that means you're actually allowing subclassing, right? So the subclasses of number consists of capital integer, long, float, double, and so on, right? Okay, so those are the ones that are possible for you to use. So how do we actually use this method then? Let's use it in our app.java here, right? So say that I want to print something. Okay, so just to make it shorter, you can actually call people.sum, right? To actually return the value that you wanted, okay? And then can I sum 1 plus 2.0 then? Okay, so if you want to print it out, of course you use a system.out.println to print the output from this people.sum, right? So I'm using the class name followed by the static method name, and then I am summing two variables of two different data types, right? One is integer, the other one is double. So how would that happen? So it sums 3. Isn't that easier? And you notice that sometimes when we write method, right, to sum two variables, they have to be of the same type. And this is something that has actually been bothering you for so long already, right? Okay, so you notice that if you want to sum two values, it has to be of the same type. So like our last time, when you use, let's say a conventional sum. So you might want to compare with your conventional sum. Okay, like let's say a conventional sum. So then both of the type must be the same, right? Like let's say integer with integer. Right? So those are the things that you need to actually do. I and j must be of the same type. If they are of different type, will it work? Okay, so you have to have a return type of type integer as well. Okay? So if this is double, will it work? No. Right? So it doesn't work. Then how? Use generic, okay? In our generic, we have this thing called bounded, data type. Right, so where we use t extends number in place of all this troublesome thing, right? So it doesn't allow you to actually do something like that. And normally, when you want to overcome this problem, you would probably want to just make this as a double, And then, okay, how do we actually convert that? Okay, so this double, then everything should be okay, right? And if one of them is a float and a double, sorry, my typo again, then that still be okay, right? But you notice that, well, the conventional sum, the troublesome thing is that sometimes the data conversion is one of the hardest things for you to actually remember, right? So here, you don't even have to actually state the type, right? We only use t, right? You don't have to state the type. How many types of methods must you create, right? If you want to sum two possible values, integer, float, double, integer with integer, right? So therefore, this is actually quite cumbersome, right? The conventional way requires you to state explicitly the type, but here, no need. As long as they are of type number, right? Anyone that extends number, including double, float, or whatsoever, can actually be used at will. Okay, so that is to say that if you add 1.1 with 2.0, it should print 3.1, right? Without any issues, right? And if you add 1 and 2, that means integer with integer, it should work as well, right? Okay, so that it prints 3.0. So hopefully you get the idea that when you use a generic method like this, you allow yourself to actually have more flexibility, right? You don't have to be bounded by the types, okay? And as long as they are of type that extends number, then it should be okay. And there's another keyword when we talk about bounded data type. There's possibility that you can actually refer to your superclass. Okay, that means it's upper bound. So when you use the keyword super, it doesn't necessarily means that it will work all the time. When you say super number, you're actually referring to the so-called parent class, which is object, capital O, and it doesn't work, okay? You notice that if you use object, all these things cannot be used, right? Because the T cannot be resolved to a type. Now it's becoming an object. So therefore, it's rarely used. So I'm sharing to you this information so that you know that there's actually an upper bound and lower bound, right? Okay? So when you use the keyword super, it means the parent class, right? And the parent has only one. And if this is a so-called sub class, then that's fine because the parent can still be used, right? So like let's say if you say extends double, would that be okay? Well, it could be okay, but it could be not okay, as you can see here, right? What actually extends double then? Okay, right? So if you say T super double, might work, might not work, okay? The word super is not normally expected inside your so-called bounded data type, all right? So this will be the example that you can actually have a look, right? When you sum two values, right? And the last thing that I want to cover is called a wildcard, right? Okay, I'm also going to use a method to actually show how it works, right? So for a wildcard, normally the wildcard symbol is used for you to specify another, like for example, if you want to use in a parameter, another so-called generic class without specifying what you want to use, then you can actually use something like this. So I'm just going to use this example to show you, right? So this is a print array method. And why is it so important? Is because this print array method allows a generic class to be used, okay? Right? And then let's call this as, okay, people2, for example. Okay? And then this is P, for example. And then I can just say P dot a certain method, okay? Right? So just to show you how it can be used here, when you say people angle bracket question mark, that means I'm using a generic class without saying which generic class I want to use, right? So that will allow more possibilities, right? And of course, this print array allows you to print any array of people type, right? People2, right? And with any type that you actually bound to it, right? So like in our case of our I have the Java here, right? So we have actually defined people2 of type string and integer. That means we can actually use the corresponding method, okay? So the corresponding method that we have actually defined in people2 is, sorry, not people2, is in, okay, I should actually put it somewhere convenient, okay? So this one, let's put it here. Right? So I can just use it directly. So now if I were to use it to print, okay, I can just use print array P1, P2 and P3, right? P2 and P3. And then it will be able to print the array as long as they are of array type, okay? But if they are not array, that's fine. Okay? So by right, it should allow you to print something. Okay? And take note that, do I need to actually worry about the type? P2 and P3 belong to two different types, right? So the angle bracket question mark is normally used in your parameter to allow a so-called generic type to be used, right? The generic class that you have defined, right? So if you want to, let's say, use people2 bracket string here, you can. If you want to use people2 bracket integer also, you can use it, right? But bear in mind that, well, this only allows a definition like this, okay? And can we just say people2 t? Not quite, right? Why? So over here, if you are passing it as a parameter, the type would have to be fixed already, right? When you use a question mark, that means I don't want to know what type is used. Okay? Right. So is that clear to you? You don't actually pass a t as a parameter, right? With an angle bracket. Remember that. In a parameter, it's already fixed, okay? So during execution of your method and so on, this would have already been fixed. But since you want to allow multiple kinds of people2 that you want to use here, right? Then you can actually use an angle bracket question mark. That's called the wildcard. So wildcard over here stands for anything, all right? And this one can be used for your example of the generic box example on top. And what it does is that it allows a box of any type to be passed in to your print array so that it can print out the value, all right? So are you all clear about this? This angle bracket question mark is only used in the case of parameter, right? Input parameter, because it allows another generic class with any type to be actually passed into it, right? But it shouldn't be t, because t is normally used for your so-called type definition, right? So the angle bracket t is only used for type definition. It's only used in your class and method, right? And not in your parameter. In your parameter, we use a question mark instead, okay? If you want to allow different types, okay? Is that clear to you? All right, so that's what you need to know. So all 5 things only for our generic class, generic method, generic interface, bounded data type, right? And followed by the last one will be wildcard. And all this will be, of course, the coverage of your generic. And we're done. Any questions? If not, then we can actually pause here.